Hello everyone, we are the Smart Devices group. We are here to present the hard hats of the future. One of the things that we've noticed is that there are still many injuries in the construction industry, and despite the trend decreasing over time, it still exists. So we looked at a way that smart devices would reduce this trend of fatal work injuries happening in the construction industry. Over time, hard hats have developed with different technologies being implemented. However, we wondered, is there anything else that we can do to add to the hard hat, like a smart device, that would make it more efficient, more effective, and safer for workers? At a high level, we realized that construction accidents happen because humans are unable to perceive existing information. It is the realm of the non-observant where accidents occur. Whenever there's confusion, surprises, or extra thinking, accidents are more likely to occur. Technology is used to reduce these accidents, to help people see without seeing. We see it in airplanes and pilots using technology in the cockpit. We see cars nowadays have sensors that alert the driver when there's someone near them. We see it being used in agriculture to make farming more efficient. And technology is used in computers to beat human beings at their own games. And now in fast food chains, technology is being used to replace workers. Driverless cars are becoming more and more popular. And we see it in large companies in distribution centers. Robots are being used in China. All of these technologies are used to reduce risks and reduce accidents, and make the job more efficient and safer for everyone. Our goal is to push the boundaries with hard hats by integrating smart devices inside of the current construction hard hat. Taking the hard hat and adding technology is like taking Tony Stark and giving him the Iron Man suit. We gathered this idea through existing hard hats, existing helmets that allow people to see without seeing. This helmet was developed in the F-35 jet that allows pilots to do all sorts of use all sorts of integrated technologies within the helmet to make decisions. We also see it in the NASA helmet, which is a very high-tech device. Our hard hat would have a headset and a microphone. The way a coach communicates to a player, the same way a supervisor would communicate to a worker. A small camera. This way, training techniques can be improved. An RFID tag. This way, workers can be tracked wherever they are on site. We'd have batteries being able to power these devices integrated inside of the hard hat. And this hat would be able to be paired with existing health trackers to monitor the health of the workers, and all monitored through a smartphone. We realize there are a few strengths, weaknesses, opportunities, and threats with smart technology integrated inside of a hard hat. The main strengths are that it would increase safety without requiring extra training, and it utilizes existing developed technologies. Our main weaknesses are that the construction industry is resistant to change. Hard hats already do a decent job of protecting the head, but we want to take that further. And with that extra protection comes a bit of an extra cost, which can be perceived as high by construction companies. Some of the opportunities are the large-scale construction sites that require extra management efforts, and the high use of human laborers. The threats are the competition. Automation is already taking place in construction, and the humans are being phased out of the job, meaning a hard hat with smart technology might not even be necessary. A use case might be the border wall. Donald Trump became the president, and he decided that America needs to build a wall between the US and Mexico. Everybody didn't believe him until an actual timeline was developed and companies began submitting RFPs for building a border wall. These are some of the ways that walls have been built. There are certain risks and characteristics involved in a project like this, like the temperature, soil, and location. The distance between is also significant, and the terrain presents risks. These risks are a threat to human safety. An information-driven hard hat would improve the ability to mitigate these risks. If a supervisor had information about each laborer communicated to them, they'd be able to track and measure performance and safety more effectively. In conclusion, a majority of the risks that we see in this potential use case of the border wall are minimized through the capability of smart technology integrated into a hard hat. Head injuries still occur despite advances in technology, and accidents are caused by the inability to perceive information. But by utilizing technology to capture information, the information-driven hard hat helps reduce accident likelihood.